Hello everyone. So this week we're going to start our discussion of continuous distributions. In those distributions, the data values can take on any value within a range. So let's think about what types of data would fit that pattern. All right, for example, suppose I'm measuring my company's product in terms of the weight of the product. All right, maybe on average, a bag is 2 kilograms. Theoretically, the bag could be 2.3 kilograms, or maybe 2.01 kilograms, or maybe 1.984, etc. kilograms. All right, so I know it can't go below 0, and maybe there is an upper limit on how much these bags could weigh. But if the bag could theoretically take on any weight within that range, then it's an example of continuous data, and therefore we're going to have a continuous distribution. Now again, think of how this differs from last week. We looked at things like how many free throws would Steph Curry make if he were shooting 10 free throws? He could make 0, 1, 2, ... right, all the way up to 10. So there's a fixed limit on the number of options in terms of how many free throws he could make. Okay, so this one would be discrete. That was last week. And then this week we're looking at things that are continuous, so that's going to be things like weight, time, and other quantities like that. All right, now let's start by looking at the world's simplest continuous distribution. This is called the uniform distribution. So think of that as every data outcome is equally likely. And the way that we're going to estimate the probability of a certain outcome is we're going to look at the area underneath the curve. All right, so here's a graph of a continuous distribution that's uniform. The data starts at some lower value, the minimum that we call the A, and the data can range all the way up to some upper maximum, the B, and the data can equally likely be any value between A and B. Now the height, if I take 1 divided by the range, so remember guys, B minus A, that's min minus the max, so that would just be the range by definition. If I take 1 divided by that, I'm saying that I have an equal likelihood of the data being any value between A and B. Now these scary looking equations on the right, every probability distribution can have a mean and a standard deviation. So this Greek letter mu on the left is the mean, and notice how it's just the midpoint of the range. And this Greek sigma on the right stands for the standard deviation, and it's just got this formula that we can just kind of use or memorize. It always takes this simple formula right here, okay? All right, so let's work an example, and then we'll do it in our guru. So let's suppose that the distribution of arrival times of a fire truck to a scene is uniform. Okay, so that means equally likely time. The minimum time is 2, so that's going to be our A, and the max is 15 minutes to arrive, so that's going to be the B. All right, let's take a look at what is the probability that a truck will reach a scene within 5 to 10 minutes. And then we'll look at some other examples. So first, before we run it, let's take a look at this graph right here. Remember we said the probability is the area underneath the curve. All right, so here's my uniform distribution for this problem. All I need to know is the A, so that's 2 minutes. The B, that's 15 minutes. I've got the 1 divided by the range, so that would be 1 over 13 in this example. And now all I would need to find is the area of the rectangle between 5 and 10 minutes. All right, now from basic high school, I know that the area of my rectangle is the length times the width, right? Or base times height, however you want to phrase it. Okay, so the height is 1 out of 13. Okay, so here's my 1 out of 13. The width would be the 10 minus the 5, so that would be a width of 5. And if I simply multiply those two numbers, I'm going to get an area, which is the probability of 5 divided by 13. All right, so the full answer is 5 out of 13. Now RGuru is very good at doing these, so let's load up RGuru and do this one there. Okay, so this is going to be under the probability section. Click your drop down, calculator, and now instead of discrete like last week, we're going to be using continuous. Okay, now what you'll notice is that the input screen is pretty similar. If you have values for the data and you want to know the corresponding probability, that would be a values to probability. So that's what we're going to start with. Notice how, just like last week, you could also start with a probability and have it return the corresponding data value. Now RGuru has some built-in distributions. So this one is a uniform. So notice you're going to find uniform in your drop-down. Now notice the only two things you have to give it are the minimum value for your data and the maximum. So in this problem, the fire trucks arrive soonest 2 minutes and at most 15 minutes. Okay, so that's your range, 2 to 15. Now again, let's take a look at the problem. We're starting with a between 5 and 10. Okay, so I'm going to click. Notice how we have in this drop down, we could do below probabilities, we can do above, we can do betweens, we can do outside. So this is going to be a between. So I'm going to click on that. The lower tail is in this case, you just want to put in this text box the lower of the two data values that you want to get. So this is 5 minutes, 10 minutes. Let's graph it. And let's see what we get. Okay, so this is really convenient. Let's take a look at the top. So we have the mean of the distribution. That's what we call the expected value. So notice how it's right in the middle. 8.5 minutes is exactly in the middle between 2 and 15 minutes. And then it gives us the variance. So I could use this directly for a homework problem. If I needed the standard deviation, I could just take the square root of the variance. It gives me the probability that the truck will arrive between 5 and 10 minutes as 0.3846, and notice that that is exactly 5 divided by 13, just like we saw in Excel. Now, it's a good trick to kind of look at your graph. Sometimes RGuru cuts off the min and the max, but notice how it is showing me that, yes, I'm seeing an area between 5 minutes and 10 minutes, so my graph looks good. And that means my answer is probably correct. All right, let's just take a look at a couple of other applications with this problem. Let's suppose you wanted to know how likely is it that the truck will arrive in less than 2 minutes, right? That would be a good thing. That means the truck is arriving quickly. Okay, back on basics. This would be a below and then 2 minutes. Okay, click preview. All right, so in this case, very unlikely, right? So it's just extremely unlikely that the truck will arrive less than 2 minutes in this example. Let's try one more. How about arriving less than 5 minutes? Okay, and now we're getting a more realistic, in this case, almost 1 in 4 times, so 0.23. How about more than 12 minutes? Right, so that would be an above. Right, so above 12. Click preview. So again, almost 1 in 4. Okay, if I wanted more than, let's say, 10 minutes, that would be above 10. All right, so that's going to be even more likely, so that's 0.38. So it's really that simple. So the problem that you guys are going to answer, let me scroll down to it. Is going to be this one right here. So as needed, just feel free to pause the video and answer this question. And I will see you guys in the next video.